I am with my other classmates, Praveen Saxena and Nirmal Shiv Kumar. I am here to present the SP assignment presentation, the design of the problem statement that has come for us for part one. We are group 60. So the problem statement is which we have given it to us for SPA, which is stream processing and big data system. So we have analyzed uh, the problem statement and we have found following things. We have to develop a community app. The community app is something like Facebook or Instagram where users can share information, and this could be visible to all relevant friends and family. Along with that, it will also provide messaging facility. Now the messaging could be, the feature is like WhatsApp where we can do direct messaging, and where a group could be created and user could share the content in group as well. And non-functional requirements side should be a scalable system with heavy load with all the security in place. It should also have analytics to do all the analysis about user behavior and pattern for recommendations and commercial benefits. And there could be there are basically three kind of data that we have to handle: structured, semi-structured, and unstructured. This the presentation that I'm going to give here, provide here, is basically having two part. One is the technical, the diagram part, and the text part. So the diagram will be supported by the text. So the when we are going to submit the PPT, the text could be used as the script for this presentation. This particular view represent high level design. Now high level design of this system, there are three parts of that. One is application layer, second is big data system layer, then data storage layer. Hardware infrastructure or OS layer is another layer, which I am assuming that it is common to every other system. Now this could be Amazon hardware infrastructure and operating system. We could use any infra provider, pass provider like Amazon, Azure, or GCP. uh, Data storage layer is meant to store the data. Now, data, when we are getting the data from different sources, it could be structured data, unstructured data, and semi-structured data. We cannot, complete all this, all the database or data related requirement into one kind of system. So we have to utilize multiple different storage. One is NoSQL DB for non RDBMS specific data. Then we will have Hadoop system, which in which we can store the files, big files like videos, audios, and then there could be semi-structured data where we will be seeing a lot of documents and other details. uh, Data storage layer have two subcomponents. One is data stores. So this data stores represent all the DB that I have explained. Storage manager is abstraction over data stores, which will just provide set of APIs for data store. So whatever data this has to be manipulated, or all the CRUD features will be exposed through storage manager. Now let's come back to big data system. The big data system is the main fulcrum of this system. It has two parts. One is stream processing engine and another is content management layer. Content management layer is responsible for all the content which is coming from uh, by different user. The bulk, the amount or the ferocity is too high that we need a big data system to crunch it. Normal system could not handle it. So we need a big data system to handle it. Now there are three components of this content management layer. One is content aggregator, another is data manager, and then this is access control manager. Content aggregator, the responsibility of content aggregator is it takes all the content, it aggregates and stores in the data storage layer. Okay. Data manager is a layer which provides the data access thing for using data storage layer. So it does a lot of things like it uses access control manager. It takes the data from content aggregator and stores into data storage layer. Access control manager, the purpose of access control manager is to provide the roles and security to the data. So who can access the data, it is handled by access control manager. It will be again part of content management layer. this access control manager. Now let's go to stream processing engine. Stream processing engine, this is for continuous data processing. So when the data this system is meant for continuous data processing. So there are messages which is coming from WhatsApp kind of application, the application for direct messaging, and then there are data which is coming from community app for feed generation. So this all will be handled by stream processing engine. Now, stream processing engine have three multiple subparts. First part is query and filter processor. Whenever the data is coming, this this particular component will see it will check whether the data or content is correct or not. Does it require validation or any kind of regulation issues which we are seeing these days, like government is asking to put a lot of filters. So this is the filter processor. Compressor, the video and the audio which comes into our system will be of high volume. We have to reduce the size of it, keeping the main content of it. So compression will be used for that. Indexer, so when user is going for searching for the data, we cannot search whole of the video system. So for that purpose we are going to use indexer. uh, uh, One of the component of SP engine is chat system. So chat system, the purpose is to enable the on the direct messaging or messaging system. It will have video, audio, and text part, which will be which will be handled separately, and then also the content sharing, because the content will be shared. Now this video, audio, and text, when I am saying it's the call, so we can have video call, audio call, and text based messaging that we can do, and then content sharing which is also based on video, audio, and text. Now this content feed provider is another part of is also part of stream post processing engine. This is for continuous feed updates from the community message app, where user could could post something and all other user can see it. The top most layer is application layer. This is the layer where user app interacts. Okay, so this is this layer will have many sub components into it. So one of the components, service framework. So what are the services user will be seeing, like add friend, timeline services, sending messages? This will become part of service framework. Second thing is big data client. As we have to interact with big data system, we have to keep client for it. UME, user services, as we have so many user is the center of this complete system. So user service has to be designed and maintained in such a way that it caters every possible scenarios. Platform services, like compression services, cross-cutting concerns like logging, exception, and error handling is part of platform services. Cache framework, to store uh, recent data, so that we don't have to do a lot of data storage layer access. We can directly get the data from cache. Group services is meant for messaging system, where we are going to send messages in the group, so it requires a separate dedicated component for application layer. Analytics is meant for analysis of the data that user is generating. Then we have WebSocket framework. Again, this is required for messaging app. Now app manager and user interface, this is meant for omni-channel representation. So omni-channel representation means the user app or user can access the system with multiple channels, be it mobile, iPad, or browser. So this is the purpose of user interface and app man. So this is the high level design of the system that we are going to develop. Let's go to, as mentioned, these are the scripts which I have explained to you here. Now let's come back to there. We have two requirements. One is community information app like Facebook, where user can post, like, comment, and share, add friends, see the timeline, see user posts and profile, and he can also see the activity logs. Uh, there are many processes or services that will be exposed to end user. One of the thing is user onboarding process. So here I will explain different process activity and how the component will play into completion of the this particular functionality. So first thing is, when user go for registration, registration of registering the user, or when he's selecting this option, user service will come into picture. It will check if the user exists or not. It checks both the places, cache framework as well as RDMS. And if it does not exist, it sends the data to Kafka services for various other, processing, like whether it is fake profile or not. And if it is not a fake profile, then user service creates a user into the system. Now, again, the Kafka service, once it the user gets created, Kafka services again comes into picture, and what it does, it starts doing a lot of backend processing, like providing a lot of recommendation and suggestions for the user, like commercial suggestions, like what are the things on the preferences, what are the things we can recommend him, and for user based recommendations, like which user, who could be the group, or who could be a possible friends of this person. uh, Now this is, for this particular flow, user service is part of the service framework of application layer. This is RDBMS, which we are going to store the user information. Again, this is part of the data store, and Kafka service is for stream processing. Cache framework is in application layer. Now we have various different kind of users for this particular this use scenario. One is their celebrity, where we have, there could be millions of users, so it requires a lot of optimizations there. Next thing is user could be active use. Now user could go live as well. For live content, he could also post the data. There are passive users who comes sometime but he does not do a lot of post. And one is inactive user, he stopped using the app itself. Now, this is that complete DB design where the person has to do the profile, he has to do location. So this will represent complete user, as user is our central to this system. We have put a lot of effort to define this DB. This is the script for what I have explained. Now, when user adds the process friends, so let's assume, when we are going to add friend, like how we do it in Instagram or Facebook, uh, user will go for adding friend service execution. Now, what will happen internally? It uses graph service. Now, graph service uses internally GraphDB. GraphDB is GraphDB is meant to create link between different users. Now, this GraphDB concept I will explain to you next slide. uh, this graph service will again use the cache framework to check whether the user is having a friendship, or there is some kind of validation that we have to perform. The graph service will use cache framework and RDBMS to execute these validations. And if everything is okay, it adds the user into GraphDB. Now, once the user is added, again the Kafka services comes into picture, and it will do a lot of processing, because there are two people are coming and joining, and there could be two distinct graph, and which is assembling. So it will create a bigger graph, and so many information could be processed with Kafka service for recommendation and commercial aspects. Now, what is the graph DB? What is graph DB and how it works? So let's assume this is the person who is trying to add this person as a friend, and this person is already having multiple friends. So what will happen when someone becomes friend? There is a graph edge that gets created here. Now, when this graph edge gets created, it creates a bigger graph. Now, let's assume there are multiple edges as well. So what will happen? It will create two disjoint graph into a bigger one graph. And using GraphDB, the calculation, the recommendation, the query becomes very easy for all the accessing the similar kind of features or friends scenario. So GraphDB provides this kind of features. Now, one thing is the next thing is user feed and timeline process. Uh, so whenever a user adds a feed, it goes to first to feed collection service. It's a central repository where all the feeds coming from different users are getting collected. It is again a Kafka service. This Kafka service will use platform services for compression, validation, and multiple user scenario. This feed collection service will, once after all the validation of security and compression is completed, it stores the data into feed store, which is a Cassandra or NoSQL DB. Now here also we can also use Hadoop or Hadoop for storing the files which is coming for video and audio. This is also place which feed store could store. Now, once all the data is in feed store, we run a feed store processor service. This feed processor service is a big data system. It's not Kafka system, but it's a big data system. But it gives a near real time, service. So what it does, it processes all the data which is coming to feed store. It filters to whom this data should be stored, or to who is responsible for this data. This kind of activity this feed process services will perform, and it will send the information to analytics, as well as this process data the system will store into another DB, which is aggregated summary. So this aggregated summary is the main data, or it is a churn data that has been collected into this store. As you know, what happens that the data keeps coming, on, for billions of users every day. What will happen that this summary will be too heavy to maintain. So what we have to be require, we require archive service, which based on, certain criteria, like which kind of user it is, as well as what is the time window. This service will take the data and put into the archive DB. Okay. Now this, due to this aggregated summarized DB will keep reducing the data volume. Now this is the this part tells how the data is stored when it is coming. Let's assume I am coming for user profile or timeline, of verification for another user. Now what happens that timeline, let's assume I'm seeing someone's timeline. Sorry, if I am seeing someone's timeline or user profile, it's the same feature, uh, but there are two flavors that could come with the same set of features. Okay, so user profile will also show you the same thing for different user, and timeline will show mine timeline only, or individuals or that person's timeline only. Now this timeline service will call feed service. Now this feed service is a Kafka service. It will keep getting the continuous data from aggregated summary, because this aggregated summary, this state DB keeps the aggregated summary data. Now, and then it will all, if user is going for, tool back, or it is trying to go to 2 or 3 years of data, it will also call archived services, and it will pull all the archive data as well. It will also fetch the data from, cache framework. Now what will happen here, a merge request will come for this feed service, and it will get all the data merged into one feed. Along with that, the timeline this feed data will be given to timeline service as well. Now there is a live feed as well that can come. So if the live feed is coming, then in that case feed collection service will send that live data to timeline service. So there are three kind of data that timeline service will be pulling: live data, uh, this feed service data. Now this feed service will pull this aggregated summary and archive service. So the user will see complete 360-degree view of the user detail or content that it has posted. This is the script of what I have explained. Now for function, for direct and this one is for meant for group and direct messaging. User can post images, videos, and it can also post text. It can also do audio call and video call. So this is the design of our system. We have user one. WebSocket handler is a lightweight component which will connect the user app with the system, and because it requires continuous connection with the system, it is some kind of lightweight server. Now the work is something like that. User one connect with WebSocket handler. WebSocket handler will perform first user service authentication or user service verification that user is correct or not. Post that, user will send the data. The data will come to message service. Message service will perform again using platform service varies validation, compression, and then it will send the data to content stream processor. The content stream processor will perform various things, like it will perform a lot of analytics, and it will compress again, or it could send it to some other system for query processing. Now now once the data is processed, it will again send to message service. Message server will select one of the WebSocket handler, which will at last send the information to the receiving user. So this is the complete process for messaging. Thank you. And this is the script for messaging, and this ends our presentation.